Welcome to the channel. In today's video, we'll dive into the exciting world of self-healing materials and how they're transforming construction and technology. Imagine structures that repair themselves or electronics that can recover from damage without the need for replacements. These groundbreaking materials are not just a futuristic idea, they are already making an impact on industries worldwide. From reducing maintenance costs to improving sustainability, self-healing materials are reshaping how we build and innovate. Stay tuned to learn more, and don't forget to subscribe for more insights on cutting-edge technology and trends. Number 5. Future potential. Self-healing materials are still in the early stages of widespread application, but their future is highly promising. As research progresses, these materials are expected to become more advanced, efficient, and cost-effective. Scientists are exploring various ways to improve their healing mechanisms, including integrating smart technologies and enhancing the self-repairing processes at a molecular level. This could allow materials to not only heal physical damage, but also respond to environmental changes such as temperature, moisture, or pressure. In the construction industry, self-healing materials could lead to buildings that maintain themselves over time, drastically reducing repair costs. In electronics, they may be able to extend the lifespan of devices by repairing wear and tear autonomously. Additionally, advancements in these materials could lead to new uses in the automotive and aerospace industries, where resilience and safety are paramount. As innovation continues, self-healing materials have the potential to transform industries by making products and infrastructure more sustainable, reliable, and cost-efficient. Number 4. Energy efficiency. Self-healing materials play a crucial role in enhancing energy efficiency by maintaining the structural integrity of systems over time. In buildings, for example, cracks or wear and tear can lead to energy losses, such as leaks or insulation breakdowns, which increase heating and cooling demands. By autonomously repairing these damages, self-healing materials help to keep buildings sealed, reducing the need for additional energy consumption. Similarly, in electronic devices, such materials can prevent performance degradation by fixing minor faults that might otherwise lead to power loss or inefficiencies. In more complex systems like aerospace, self-healing materials reduce the frequency of repairs and ensure optimal performance, which is vital for energy-intensive operations. By extending the lifespan of these systems, self-healing materials not only contribute to energy savings, but also lower the environmental impact associated with manufacturing, repairing, or replacing damaged components. As the technology evolves, the integration of these materials in construction and tech can significantly improve overall energy sustainability. Number 3. Innovative applications. Self-healing materials are making significant strides across various industries, such as construction, electronics, and aerospace, due to their ability to autonomously repair damage. In construction, these materials are used to create buildings and infrastructure that can automatically seal cracks and fractures, reducing repair costs and improving safety. This is particularly beneficial in harsh environments, where frequent maintenance is costly and challenging. In electronics, self-healing polymers are applied in flexible devices like smartphones, wearables, and sensors, ensuring they remain functional even after minor physical damage. This increases the product lifespan and enhances user experience. In aerospace, self-healing composites are utilized in aircraft and spacecraft to maintain structural integrity and reduce the risk of critical failures. These materials automatically heal when exposed to damage, ensuring the safety and reliability of high-performance vehicles that operate in extreme conditions. The potential of self-healing materials is vast, and their continued development promises to revolutionize industries by improving efficiency, safety, and sustainability. Number 2. Increased sustainability. Self-healing materials contribute significantly to sustainability by extending the lifespan of structures, devices, and products. Unlike traditional materials that require frequent repairs or replacement, these advanced materials can autonomously fix cracks, damage, or wear and tear, reducing the need for costly interventions and material waste. In construction, for example, self-healing concrete can repair cracks that form over time, preventing structural deterioration and reducing the need for new construction materials. This results in less consumption of raw materials and lower carbon emissions associated with manufacturing and transportation. In electronics, self-healing coatings or components can extend the life of devices by repairing damage to their surface or circuits, reducing e-waste. This characteristic is crucial in a world focused on reducing environmental impact and promoting circular economies. By decreasing maintenance needs and the frequency of replacements, self-healing materials also help reduce energy consumption throughout their life cycle, further enhancing their sustainability credentials. Overall, these materials are paving the way for more resource-efficient and eco-friendly solutions across various industries. Number 1. Enhanced durability. Self-healing materials significantly improve the durability of both structures and devices by autonomously repairing any damage, such as cracks or fractures, that occur during use. These materials typically contain microcapsules, or microfibers filled with a healing agent. When a crack forms, the capsules break open, releasing the healing agent that flows into the crack and solidifies, effectively sealing the damage. This process can occur repeatedly, offering continuous protection over time. In construction, this means buildings and infrastructure can remain safe and functional for longer periods, without the need for frequent repairs. For technology products, such as smartphones or wearables, self-healing materials can keep devices operating at full capacity, reducing the likelihood of failure due to physical damage. This capability reduces repair costs, enhances safety, and contributes to a more sustainable, long-lasting solution for industries relying on high durability, ultimately lowering maintenance demands and reducing downtime. The result is an overall increase in the life expectancy of both buildings and tech products. Thanks for tuning in to explore how self-healing materials are transforming construction and technology. These innovations are pushing the boundaries of what's possible, offering incredible potential for both industries. If you enjoyed this deep dive and want to stay updated on cutting-edge trends, don't forget to hit that subscribe button for more exciting content.